So this is another joint piece of work with Orla, myself, and our colleague Amelie from Northwestern University. It's possibly not as close to completion as some of the other pieces of work you've seen today, so I'd really appreciate any feedback that you might have. If you have any questions throughout, just shout up at me or wait till the end. Okay, so we've seen today that PFL seem to be generating a lot of treatment effects, be it on child health or the home environment. What we haven't looked at explicitly as of yet is variability in treatment or dosage. So within PFL, there's actually quite a lot of variability in treatment, even among the intervention group. So by the time the child turns 2, some participants in the treatment group have only received about 5 visits, whereas other participants in the treatment group have received over 80 visits in that same span. So what we're trying to answer in this paper is how does that variability affect outcomes? And if we do see a difference in outcomes associated with different number of visits, can we attribute that to different levels of dosage? Or is that simply selection effects? And then if we're able to maybe put an estimate on how valuable in terms of child development an extra visit is, then we might be able to make some policy recommendations in terms of implementation targets and things like that. From a policy point of view, delivering these home visits is actually extremely expensive. So a survey of 25 different home visiting programs in the US revealed that the average cost of one home visit was in the region of $500. So it's not a trivial point. Okay, so yeah, the vast majority of experimental studies rely purely on intention to treat estimates. So that's basically going to give you the average program effect, comparing all the treatment participants to all the control participants, but it's going to ignore variability in treatment within that. So certain nuanced program or intricate program effects might be masked. Those studies that do take into account treatment intensity or dosage sometimes don't do it in a particularly nuanced manner, so they might just look at a high treatment subgroup within the treatment group and then fail to take into account any sort of selection effects. Obviously it's not as relevant in certain like medical trials and stuff where the dosage is precisely controlled, but in behavioural interventions such as PFL, where the most important impact on determining participants' dosage is their willingness to engage. So there's the potential for self-selection, and families can exert influence over the level of treatment received. So just in terms of some of the econometric issues at play, similar to Therese's work on maternal employment, we've got a major possibility of self-selection. So it could be that participants who tend to receive more visits are different in other ways, and that would impact our outcomes of interest, which in this case are child development outcomes. So I think without looking at the empirics, I think you can make a reasonably convincing argument that bias could go in either direction. So it could be the case that participants with better baseline outcomes realize the importance and the value and the help they're being offered as part of PFL, and so they might choose to engage more. Or it could be the case that participants with poorer baseline outcomes make up for lack of support in other areas of their life by engaging more in the program. And depending on which direction that goes in, it will bias our effect one way or the other. Also, there's going to be some there'll be some measurement error, because although we observe the number of home visits and the length of those home visits, we don't have information, and you're never going to have information on the intensity of the intervention delivered within each of those visits, so there could be some sort of attenuation bias as well. Okay, so what are we specifically going to be doing? We're going to be looking at dose-response relationships, mapping the relationship between number of visits and child development outcomes in PFL when the child is 24 months old. So first of all, we're going to present normal intention to treat outcomes, comparing the entire treatment group to the entire control group. And then we've got 3 further methods to account for selection into dosage. The first is a simple subgroup analysis. So we're going to define a high dose portion of the treatment group and then compare them to the control group rather than all the treatment group to the control group. We're going to do this in 3 different ways. The first is a normal OLS regression. The second is propensity score matching. I'm sure everyone's sick of hearing about propensity score matching at this stage. We've got a little bit more. And then our permutation-based hypothesis testing. So this method involves binarizing dosage in a kind of an artificial and arbitrary way. These next 2 methods look at dosage in a more linear sense. So we've got generalized propensity score matching, which is a similar idea but allows for multi-value treatments, and then our instrumental variable approach. So these first 2, A and B, both rely on selection on dosage being conditional just on observables, whereas if we find a valid instrument, well then all the endogeneity associated with dosage, if it is present, will be eliminated and we won't have to worry about unobservables at all. Okay, so you've seen this before as well. This is the design of preparing for life. The most important thing in regards to this present study of the design is that triple P is not relevant. So we're looking at 24-month child development outcomes. Triple P was only delivered post the child's second birthday. So no participants in the study would have received triple P as of yet. So the primary measure of treatment intensity or dosage that we're going to be looking at is simply the number of home visits through the mentoring. So we see that 115 were randomized into the treatment group and 118 in the control. By the time we get to the 24-month evaluation, there's about 82 participants in the treatment group and 85 in the control. Okay, this has already been covered again, so just in terms of the recruitment and randomization, it took place over a 2-year period between 2008 and 2010, and approximately half of the eligible population were recruited. What kind of data are we going to be looking at? So we've got the baseline data, which is going to serve for our matching and for our conditioning. We see that the two groups were equivalent on 90% of the baseline measures. Given that, similar to what Katrina was saying, given that 2 of our 3 dosage selection models rely upon selection on observables, it's important to have as rich and varied as possible of the baseline data set, because this will determine the amount of bias that will be reduced or eliminated. And so then our child development outcomes come from the 24-month interview. And again, the 2 groups are approximately equivalent at this time point as well. Okay, so what specifically are we going to be looking at? We're going to be looking at 13 maternal reported measures of child development. And we're going to standardize all of these measures to have a mean of 100 and a standard deviation of 15 to ensure comparability across measures. We're going to divide up the child development instruments into 3 categories. The first is cognitive development, which measures things like information processing and language learning. That's going to be measured by 2 domains of the ASQ. The DP3, which we've already talked about today, is Catherine's home paper, and the communicative development inventory, which is a measure of language. Then our social emotional or non-cognitive development, which measures ability to regulate emotions and stuff like that. And so that's going to be measured by the CBCL, the Child Behaviour Checklist, the BITSI, and 2 more domains of the ASQ. Finally, physical development, which relates to minor and major muscle mass control, which is measured through gross and fine motor skills, which are the final 2 domains of the ASQ. Okay. So what do the patterns of engagement look like by the time the child is 2 years old? So we see that on average about nearly 36 visits were delivered. And so if the target, which it was soon after the program started, the target was once every 2 weeks, then only 57% of visits were delivered. This is consistent with other home visiting programs where about half of visits are not delivered. The average visit took just under an hour. So you can see that about 15% of participants received fewer than 20 visits when their child was 2 years old. 40% received 20 to 40 visits, another 40% 40 to 60, and the final 5% received greater than 60, with the highest being 82. So the number of home visits delivered will in theory depend on the mentor's perception of participant needs, but by far and away the most important factor will be participants' willingness to engage. So that could manifest itself in terms of difficult to contact. It could manifest itself in terms of making appointments to meet mentor and then not showing up or not being at home and all things like that. So there's also one other thing. So depending on when the participant joined the program, that will also determine their dosage to a certain extent, because that will if they joined early in pregnancy, they'll have more opportunity for visits pre-birth. So although we're looking at everyone when the child is 2, their program length will vary slightly, because some people will be at different terms of their pregnancy when they join. So as a robustness check, instead of looking at number of home visits total, I looked at number of home visits post-birth, and we found pretty much the same thing. And as another robustness check, I looked at total amount of time in visits as opposed to total number of visits, and we found the same thing. Okay, so we spoke at the start about potential selection issues. So just to have a brief look at that. So this table lists various different baseline characteristics here and here, and then we have pluses, minuses, and NSs. So a minus indicates that this particular characteristic was negatively associated with dosage. A plus means that it was positively associated with dosage, and an NS means that it was not significantly associated. So as we said at the start, it's a bit of a mixture. So we've got things like IQ, which is obviously higher, is a better outcome for the mother, and women who are have a higher IQ do engage more with the program, but then women who are unemployed also, women who are employed also engage less. So things kind of go in a different direction. Women who have a higher knowledge of child development engage more, but then women who have higher consideration of the future engage less. So it does seem to be a mixture. The women who engage more do seem to be definitely different from women who engage less, but it's no clear pattern of advantage or disadvantage between those two groups. But it's certainly something that will be important to control for. Okay, so just to talk a little bit in more detail about the methodology. First of all, we've got the intention to treat analysis, which includes all treatment and control group participants, and the only included covariates or matching variables in that case will be those small number of variables where there was baseline imbalance. Then we've got the subgroup analysis, which compares participants who received greater than 35 number of visits, which is the median number of visits at 24 months. And it compares that specific subgroup of the treatment group to everyone in the control group. In this case, the covariates and the matching variables will be the variables which predict membership into that high dose treatment group, and also the variables where those specific groups differ on baseline measures. The three ways which we're going to conduct both the intention to treat analysis and the subgroup analysis are, first of all, standard OLS regression t-tests, binary propensity score matching, which in this case is going to be a radius matching procedure. And so as we know, that matches participants with similar characteristics. So we match people in the high dose treatment group with control participants who we think would have been in the high dose treatment group had they been allocated to that group. So it's looking to kind of isolate the causal effect of dosage irrespective of baseline characteristics. And then finally our permutation-based hypothesis testing, which again controls for the same variables, which is non-parametric and distribution-free, and basically works by shuffling the treatment assignment of various different participants and then examining the pattern of outcomes. And if the pattern of outcomes changes following the shuffling of assignment, well then we've got a good idea of whether treatment matters in the first place. Then we've got two more methods to look at dosage in a more kind of a continuous setting. First of all, there's the generalized propensity score approach. And so the generalized propensity score approach allows for the estimation of average causal effects with multi-value treatments. So instead of Therese's paper, where there's just a binary treatment of mother working or mother not working, here we could have anywhere from 0 to 80 visits. So we've got a multi-value treatment. So what this does is that it generates a generalized propensity score, which is like a conditional density function, and then it adjusts for this conditional density function within strata of the treatment variable. So this has the effect that within specific strata, the probability of a treatment taking on a specific value does not depend on these covariates. And so in the exact same way as binary propensity score matching, the extent to which bias is reduced depends on the richness and quality of included controls. Finally, our instrumental variable. And I should say that both of these methods are restricted purely to the treatment group. The control group are not in these two sections of the analysis. Okay, so finally our instrumental variable. So lots of kind of center-based interventions use things like how far away participants live from a particular intervention site as an instrument. Obviously when the intervention is home-based, this is not appropriate. So we came up with a different instrument which is based on mentor disruption. So at the start of the program, each participant in the high treatment group would have been assigned a mentor with the intention that that mentor would persist with that family for the entire intervention. Sometimes this wasn't possible because some of the mentors left to take on new positions. Some of the mentors left temporarily to take sick leave, or they might have taken maternity leave. And so this meant that by the time of the 24-month evaluation, approximately a quarter of all participants had experienced some form of mentor disruption, which means that they did not have the same mentor the whole way through the program. Anytime this would have occurred, they would have been assigned a new mentor straight away. But that's our instrument, is mentor disruption. And so we found that participants who did experience some disruption, unsurprisingly, had fewer visits on average. And the reason why this is a valid instrument, or we think it's a valid instrument, is that this should in theory be outside the participant's control. So they won't be able to control whether their mentor leaves to go on maternity leave or their mentor takes up a new job. And so the exclusion restriction, that the assumption we must make, is that the only channel through which mentor disruption could influence child developmental outcomes is via its impact on the number of home visits. If there's another channel by which mentor disruption could impact child development, well then our exclusion restriction is violated. But maybe we can talk a bit more about that at the end of some of the questions. Okay, so then our results. So first of all, our intention to treat results. So you see we've got our measures here on the left-hand side. We've got our two means for treatment and control, and our 3 sets of p-values for the OLS regression t-test, the propensity score matching, and the permutation test. So this is everyone in the treatment and control group, so this does not take account of dosage as of yet. We see for the 2 columns of means is that, broadly speaking, the 2 columns of means are very similar. So all the measures have been standardized to a mean of 100, as I say. And so the biggest difference is for DP3, it's in the region of 4%. So the treatment mean for DP3 is about 102, and the control mean is about 98. This is statistically significant at the trend level in 2 of the 3 tests. But by and large, the treatment and control means for the whole sample are very similar. In total, of the 13 measures, 8 of the mean differences are in the hypothesized direction, but they're very small differences. Okay, so what if we exclude the low-dose treatment participants? What if we just look at a subgroup analysis where we include the high-dose treatment participants and compare them to control participants? And this is what we find. Broadly speaking, it's a very similar story. So the means, again, are very similar. DP3, the mean difference is about the same. It's now non-significant because of the higher standard errors associated with the smaller sample size. And now 9 of the 13 treatment means are more favorable than the control means, but broadly speaking, the high-dose treatment group is not outperforming the control group by a larger amount. So it doesn't seem as though looking at dosage in this sort of a binary way is showing us any significant dose-response effects. What if we look at it in a more continuous setting? Okay, so first of all, the generalized propensity score. So here we've got our measures again, and in here these are our coefficients. These aren't p-values anymore. And we see that we actually have a finding, a non-hypothesized finding. So this negative finding indicates that an increased visit leads to a 0.5 percentage point drop in ASQ gross motor score development, which is plotted here by this blue line. So the top line and the bottom line here are a 95% confidence interval, and our middle line, the blue line here, is our estimated dose-response curve. We see that that's quite narrowly defined between 20 and 60, where the majority of the sample are found, but then it's quite high standard errors at the 2 tails. And so we see that that's kind of a downward sloping pattern as the number of visits increases, ASQ gross motor score falls, which is not what we would expect. There could be 2 reasons for this. Well, there could be lots of reasons, but I'm going to put forward 2. So first of all, it could be that this is based on unobservables. So while these methods, the subgroup methods and the generalized propensity score methods, both take account of observable differences between those who receive few visits and those who receive relatively more visits, there's no way that we've taken into account unobservables. So this could be kind of a spurious effect, which is not actually attributed to number of visits, or it could possibly be a real effect. Maybe the IV will clear that up in a second, but maybe it's to do with an over-reliance. So if people choose to take a large number of visits, they could maybe not parent in a productive way in other areas of their life. So they could feel as though I received so much intervention as part of my life, I received so much help as part of this intervention that I don't need to do anything else. But hopefully we'll clear that up now. So the final thing is the IV results. So the first column is just normal OLS with controls, and we see that our ASQ gross motor score finding is repeated. So again, we see a downward trend. However, when we go to the IV, this is our second column of coefficients, we see that that coefficient is not only non-significant now, but the direction is reversed. So that would indicate a strong likelihood that both the OLS finding here and the GPS finding are based on selection into dosage on unobservables. So despite the fact that we've a relatively rich set of baseline characteristics, which we include in the GPS results and in the OLS results, that it doesn't seem to matter that selection, assuming our instrument is valid, that showing that selection based on unobservables, once you take them into account, this effect disappears and the coefficient becomes positive. It's interesting that a normal OLS model produces pretty much, the coefficient is smaller, but produces the same conclusion as this fancy generalized propensity score model. Doesn't say a lot for that, I suppose. Okay, so just in terms of conclusions there, in terms of, first of all, the empirical implications, so there was very few significant treatment effects either in the intention to treat models or our dosage or dose response models. So the PFL program does not seem to be having a huge impact on these measures at this time point. I still think it's important to provide a template for estimating dose response curves, both maybe in later waves or our own evaluation. So we could do this again in 48 months with our our non-maternal reported measure of child development, and also for other studies. Maybe if there were more significant results, it would be easier to see some of the important differences between the methods, and also maybe easier to put an actual value on the per visit in terms of child development outcomes. So yeah, maybe then if we were to repeat this analysis at 48 months, we'd be able to make a better policy implication in terms of kind of dose response targets and things like that, and also kind of practice implications into how many visits programs should be targeting. Cool, thanks very much.